Good morning, dear 10th class friends. Now, today we are discussing first about the real and virtual images. Okay, so what is the real and virtual images? So first we have to write one small criteria. On the behalf of that, we have to categorize what are the real and what are the virtual images. Okay. Yesterday we already discussed about the what are the nature of spherical mirrors. Okay, it means the what are the nature of spherical surfaces. Okay, so first you have to write the definitions and the differences between the real and virtual images. So you have to note down. So it is formed by when reflected ray actually meeting at a point. It means after the reflections, when the incident ray just fall or strikes on one surface, okay, reflecting surface, and when they just reflected, and if the rays are, it means the beam of light which is actually meet at a one point, then there is a formation of real image. Okay, that is the principal focus. Okay, and that is the real principal focus also. So it is formed by when reflected ray actually meeting at a point. It means if there is a fixed point in the front of the spherical surfaces, then it is making the form of real image. Okay. Then virtual image, it is formed by when reflected ray appears to meet at a point. Appears to meet at a point. Okay. So it is formed by the when reflected ray actually meeting at a point, and then it is formed by when a reflected ray appears to meet at a point. It means they are showing the virtual image, and this will be formed inside the surfaces. That means the spherical surfaces, and sometimes that focus is formed, that also known as virtual principal focus. Okay. Next point is real image. It can be obtained on the screen. It can be obtained on the screen, and it cannot be obtained. It cannot be obtained on the screen. It means if there is a white surface or screen is that, then we can obtain this real image on the screen, but the virtual image which is formed virtually inside the surfaces or maybe the spherical surfaces, we cannot be obtained on the screen. We only can to see as the appearing only. Okay. Then third one is it is formed only for concave mirror and convex lens. Okay, and it can be formed. It can be formed for plane surface, spherical surfaces, and spherical lenses. Okay, so it can be formed for plane surface, spherical surface, and spherical lenses. Then fourth one is this image always form inverted image. This image always form the inverted image. Okay, and this one virtual image nature is always erect. Okay, and for example you have to see like that in cinemas. You have to write here example. Okay, in cinemas and in projectors, or example in the mirror. Okay, or mirror, or maybe the shaving mirrors, or anything you have to tell that, or maybe the dentist mirror. Okay, then you have to write in the shaving mirror, dentist mirror, okay, etc. So I hope you are understanding what is this. Okay, so what I am telling, you have to understand and focus on them. Real image and virtual image, it is formed when reflected ray actually meeting at a point. It means when you will see that in the concave and convex mirror, then look, rays are actually intersect to each other at a one point. Okay, rays are actually intersect at a point in the front of that our mirror. Then it is a principal focus formation here, and this is known as a real image, because we can get this image on one type of maybe the screen, like the white screen or anything. So this image we can get in the front of that. So that's why it is a real image, and this is the concave mirror, and that's why we have to write concave mirror and convex lens. Okay, when we will study about the convex lens and about the lenses, spherical lenses, okay, study, then we will also see that how the convex lens nature is like that. And shortly I can draw like that. This is the nature of convex lens, and when rays are meeting at one point. Okay, so this is the one point and rays are meeting here, so we can get this one and this one at the screen. That's why they are forming the real image. That's why they are forming the real image. But in the virtual image, okay, in the virtual image, when we are talking about the convex mirror, okay, when we are talking about the convex mirror, then virtually it is a meeting at a point inside the mirror. Okay, inside the mirror. Look that when you will see from the outside, okay, then you will see the rays are coming from a particular focus which is inside the mirror, and this is the our virtual focus. Okay, and we cannot get this image on the screen. Okay, so and just appears is like that, one light which is coming from inside a particular principal focus, that is the virtual focus, but actually that is not coming from the inside. This is the just reflected back through this mirror. Okay, so this is virtual focus, and here it is the formation of virtual image which we cannot get on the screen. So I hope you are understood about that. Okay, and this is the shape of our concave lenses. Here it is also happen in this. Okay, but we will study about afterwards. Okay, about the lenses. Here we are only describing the natures of mirrors only. Okay, so it is our real and virtual images. So look, next line is, it can be obtained on the scan, it cannot be obtained on the screen. It is formed only for concave mirror and convex lens, and it can be formed by plane surface, spherical surface and spherical lenses, because sometimes conditions are in this way where the formation of real virtual image also formed in this way. Okay, then virtual image nature is always erect. Okay, when the virtual image will be formed, then it will be the erect, because the virtual image is always formed on the principal axis. Okay, upper line of, it means the upward side of principal axis. That's why the virtual image is always formed erect in nature. Okay, and the image always formed inverted image in the real image, because those image which is formed before at that, they are the inverted image at the downside. Okay, so due to the downside their nature is inverted, and due to the upside their nature is erect. So always when the formation of virtual image, they will be the erect and virtual. Okay, and the real and inverted in the image will be the form. Then next is, in cinemas, in projector, there is a real image and virtual image. There is in the shading mirrors or the dentation mirror they are using. Now we are talking about the some rules of spherical mirrors. Okay, so you have to write that rules of spherical mirrors. Rules of spherical mirrors. To obtain image. To obtain images. First rule is that, okay, I will draw here diagram also. So you know about that the line which is passing through the center of curvature, okay, and this is maybe here formation of principal focus and the pole, which is known as principal axis. And if a ray of light or beam of light which is parallel to the principal axis, okay, after just reflect, it means after reflecting, it will be goes through the principal focus. Okay, so how is the nature? I will tell here. Look at. So this is the focus. This is the beam of light which is parallel to the principal axis. You also have to tell this is the light of incident. Okay, and after the passing through the concave mirror reflecting surfaces, it passes through the principal focus. Okay, so for first rule you have to write when a beam of light, you have to write also when a beam of light which is incident to reflecting surface after reflection passes through principal focus. Okay, so this is our first rule. It means if any ray which is striking to the concave mirror surface, okay, after reflection it just passes through the principal focus. Okay, so this is our first rule. Second rule is if a ray of light which passes through center of curvature after reflection, it just reflect on same path. It means if this is the diagram, then if any ray which is passing through this center of curvature, then it will be passed again on the same path of center of curvature. Now the third one rule is when a ray of light which is passes through principal focus after reflection will be parallel to the principal axis. Okay. Then if any ray directly incident the pole of to the pole of a reflecting surface reflecting surface in this condition making principal axis as a normal and reflect reflected in other direction with same angle it means that if a ray is directly incident to the pole, it means here, then in this condition, okay, I'll make here more understanding. Look at here. Okay, once again we have to remember these things. Four rules are there for the spherical surfaces. Okay, what are the four rules here? When a beam of light which is incident to reflecting surface after reflection passes through a principal focus. Okay, so this is the incident beam of light. Okay, initially it is incident on the reflecting surfaces. When it is reflected, then it is just passes through the principal focus. Okay, so this is the rule number one. Second number is if a ray of light which passes through a center of curvature. It means if a ray of light which is passes through a center of curvature after reflection, it is just reflected on the same path. It means if a light which is reflected on the center of curvature. If you know about that, yesterday we already discussed about that. What is the center of curvature? Actually, center of curvature is the center of the sphere. Center of curvature is center of the sphere. It means if light, if you have to draw like this diagram, then if this one is showing the reflecting surfaces of like concave mirror surface, then actually this is the center of the sphere, that is known as the center of curvature. Okay, so it means that if any light rays is coming like this way, then it will be goes in the same direction. Okay, so I hope you are understanding. It means if any incident light which is passes through the center of curvature after just reflecting, okay, it is passing through the same along the same path which is the it means again go to through the center of curvature. So when a ray of light which is passes through the principal focus, so it is the just reversal form of rule number one. Okay, it means any light is parallel to the principal axis, then passes, if after reflection it is passes through the principal focus, and then if the any light is incident, it means or passing with the principal focus, then after reflection it will be the parallel to the principal axis. So look here, when a ray of light which is passes through the principal focus after reflection will be parallel to the principal axis. So this is the principal axis. Okay, so this is the principal axis and this one is a parallel to the principal axis. Okay, and fourth one, if any ray directly incident to the pole of a reflecting surface. Okay, it means if any ray which is directly coming in the form of incident ray to the pole of the reflecting surface making same angle with the normal, it means it is just behaving like that. Okay, if the formation of I, it means the angle of incidence, then again making the principal axis as a normal, formation of angle of reflection, that is the small one r. Okay, So surface in this condition making principal axis as a normal and reflected in other direction with the same angle. So formation of angle here, it means the sin I is equal to sin r. Okay, so angle is between the angle of incidence and angle of reflection is equal if any incident ray is just directly reflected from the pole of the mirror. Okay, so I hope you are writing, and if anyone is remaining, then first you have to write. Okay. Now students, we are studying about the image formations. Okay, so now the image formation by the spherical mirror. So there are totally 6 positions. On the basis of that, we can form the different type of images. So first of all, we have to see the object position, then image position, and then what will be the nature of that. It means the position of object. Okay. So first we have to write position of object, and this is very important thing for you. Okay. Position of object, then position of image, nature of image, so on the basis of the ray diagram we will understand these things. Okay, look, first number, object in between F and P, means we have to write the object in between focus and O. It means within the focus. Then so you also have to write first. Okay, after that we will understand these things. You have to write also. So stop writing. First we have to understood about what we wrote here. Okay. So these are the 6 different type of position of object. Okay, which we can see in the ray diagrams. Okay. So somewhat you have to understanding. Okay, things. Look, these are the position of object. It means where we have to have the object when we are making the position of image in the front of mirror. Okay, so these are the concave mirror. You know about that. These all are the shape of concave mirror. Okay. So when we are putting the object in between the focus and pole, in between the focus and pole, it means within the focus. Okay. So this is the focus and this is the pole. So in between that we are keeping this object. Okay. So look that when we are keeping the object, these are the A and B is showing the object size. Object size. So this A and B when we are keeping in the it means between the pole and F, then the formation of virtual and erect image is just behind the mirror. Okay, virtual and erect. So that's why generally due to this reason dentists use to see the small teeth in the dentist mirror, because they are using the concave mirror surface. Concave mirror surface. It means when they are keeping the dentist mirror in within the focus, they can see the highly enlarged image and virtual and erect in their mirror. Okay, so these are the position of the object and they can see the virtual image inside the mirror. Then next position, okay, you have to come like this in this way. First we have to keep between the P and F, then we have to keep the object on focus, then between the C and F, it is our third position. Fourth position is at C, fifth position is just beyond the C, and sixth position is at infinity. Okay. So in this way we are drawing this diagram. So if we are keeping the object position of object on the focus, then the formation of position of image at the infinity. So you have to see this is our focus. Okay, when we can watch here like that, when we are A and B, this is the and this A and B size of the image object. So the image will be formed at the infinity. Image will be formed at infinity. The image, because of that, in the front of mirror, that's why real and formation is just below the principal axis. That's why it is the inverted image. That's why it is inverted image. And highly enlarged or highly magnified, both are same thing. And very highly enlarged image will be the form. Next is, if we are keeping the object in between focus and center of curvature. So this is the focus and this is center of curvature. Always we just keep this object on the upper side of this principal axis, and formation of image is just beyond the C. So beyond C, formation and real and inverted and magnified, it means somewhat it is not equal to size of the object. It was somewhat bigger than the size of the object, and formation of this image magnified. Okay. Then if we are keeping the object at C, then again formation, it means now the formation of image on the at least C, real and inverted, same size of the object. So look, this AB is the size of the object when the ray. Okay, why we are chosen to first study the rules here, because we know that if the ray is passing through the it is from the where the incident light is where is from coming, and how much reflection and how their reflection path it will be the like that. So look here, we already discussed about that. If a ray is incident on the concave mirror, then it is just passes through the principal focus. Now you can watch here how this is principal. And if a ray of light which is passes through the principal focus, after reflection it is just parallel to the principal axis. So you can see here. Okay. So this is A dash, B dash is the height of the or size of the image. So this is the formation and same size of the object. Now beyond C, if we are keeping the object beyond C, then formation of image is between C and F. Okay. So look that beyond C, this is the C. Okay. And beyond C I kept this position of object and formation of image here. But now the image is somewhat diminished. It is smaller in size or in comparison to size of the object. So that's why it is formed between the center of curvature and F. Okay. Now if we are keeping the object at infinity, then formation is at F, that is the principal focus just made here, and due to downside, that's why inverted, and due to front of that concave mirror, that's why real, and highly diminished because at infinity position of object may be bigger one size, but at the app the size of object image is very short in nature. Okay, so this is A dash and B dash is the size of image. Okay, so I hope you are understanding what is the what things are written here, and you should draw here. Okay, now. Okay. Okay. So right here, uses of concave mirror. Used by dentist, okay, to see the used in solar cooker to concentrate light, light of reflectors used as a shade mirrors. So I think there are 4 or 5 used for that. So they can be used by shading mirrors. So used in solar cooker to make concentrate. So what is the nature of this concave mirror? To make concentrate the light, and you can see this easily through this way. Okay, because when the infinity of light, then it can be having a capacity to concentrate on the focus. So used as a saving mirror and used in the torches, reflectors, and beacons headlights. Okay, so these are the uses of this concave mirror. In next online study, we will discuss about the rules of image formation by the convex mirror and the uses of convex mirror and the mirror formula. Okay.